Welcome to the Data Science Rabbit Podcast, the official podcast of the Data Science Rabbit Hole. I'm your host, Michael Bagalman. Hold on to your pocket watches, because we've just tumbled into the double-digit wonderland. That's right, we're 10 episodes deep and showing no signs of slowing down. We're like Alice after she's had a sip of that drink me potion, growing bigger, bolder, and more bizarre with each passing week. In this episode, we're diving headfirst into the Mad Hatter's Tea Party of Simplicity, the KISS principle. We'll be learning why sometimes in the world of data science, less is more. Unless we're talking about data, in which case, bring on the terabytes. But wait, there's more. We're also taking a trip down memory lane, because those who don't learn from history are doomed to repeat it. And as if that wasn't enough to make your neural networks tingle, we've got a special guest co-host, the Cheshire Cat of data science himself, to remind us all that behind every great algorithm is an even greater data scientist. Sorry, HAL 9000, but in this story, the humans are still the heroes. So, strap on your bunny ears, adjust your waistcoat, and get ready to fall down the rabbit hole with us. Come along and join the fun. This podcast is proudly sponsored by the Outlier, because every dataset needs that special someone who doesn't quite fit in. Why be normal when you can be exceptional? Outliers, making statisticians sweat and machine learning models question their existence since the dawn of data. Remember, one man's noise is another man's Nobel Prize-winning discovery. Embrace your inner outlier today. Today, we're talking about a principle so simple, it'll make you wonder why you've been overcomplicating things all along. Keep it simple, stupid. KISS. Not the band, although their makeup was anything but simple. No, we're talking about the design principle that's been around since the 1960s, yet seems to have gotten lost in the labyrinth of big data and machine learning algorithms. You know, in an era where ordering a coffee requires a PhD in linguistics, I'll have a venti, half-sweet, non-fat caramel macchiato with an extra shot and light whip. It's no wonder complexity has taken the front seat, leaving clarity waiting at the bus stop. But in data science, complexity isn't just annoying, it's downright dangerous. Dig this. You're a data scientist at a Fortune 500 company. You've just spent months building a neural network so complex, it makes the human brain look like a kid's connect-the-dots puzzle. You've used every fancy algorithm in your arsenal, incorporated more features than there are stars in the Milky Way, and your model can predict everything from stock prices to what your CEO had for breakfast. You're feeling pretty smug, aren't you? But then comes the moment of truth. You present your masterpiece to the executive board, and their eyes glaze over faster than a donut at Krispy Kreme. They nod politely, thank you for your hard work, and then promptly ignore every insight your model generated. Why? Because they couldn't understand a damn thing you said. Here's the cold hard truth. The value of data science isn't in the complexity of its tools, but in the clarity and directness of the solutions it offers. We're not here to show off our fancy algorithms like they're trophies in a high school display case. We're here to solve real-world problems. And last time I checked, the real world doesn't speak in terms of gradient boosting and eigenvectors. So, how do we embrace simplicity in a field that seems to thrive on complexity? Well, it's simpler than you might think. See what I did there? First, start with the problem, not the solution. Too often, we data scientists are like kids with a new toy. We want to use our shiny new algorithm on everything. But remember, if all you have is a hammer, everything looks like a nail, and trust me, not every problem is a nail waiting for your neural network hammer. Second, aim for interpretability. If you can't explain your model to a 5-year-old, or your CEO, same difference, it's probably too complex. Strive to make your data models so simple yet sophisticated they could walk down a runway at a fashion show and get a standing ovation. Third, embrace the power of visualization. A picture is worth 1,000 words, and in data science, a good visualization can be worth 1,000 lines of code. If you can convey your insights in a clear, visually appealing way, you're already miles ahead of the data scientist who's still trying to explain what a p-value is. Now I know what you're thinking. What about accuracy? Don't we lose accuracy and precision when we simplify? Well, let me hit you with some wisdom from the world of statistics. All models are wrong, but some are useful. A simple model that's 80% accurate and can be implemented is infinitely more valuable than a complex model that's 95% accurate but sits gathering dust because no one understands it. Remember, we're not here to win a complexity contest. We're here to make a difference, to provide insights that can be easily understood and implemented by leaders, no matter their grasp of technical details. We should be the stealthy ninjas of the business world, meeting needs quickly and quietly, not the peacocks showing off our fancy feathers. So next time you're knee-deep in a project, drowning in data and algorithms, take a step back and ask yourself, am I just adding bells and whistles to see if I can? Or am I actually trying to keep things as straightforward as a bedtime story? Are my insights so clear they could be understood by someone who thinks SQL is a new sports league? As the great Clare Boothe Luce once said, simplicity is the ultimate sophistication. So let's aim to be the most sophisticated data scientists out there by keeping it simple, stupid. Now I want to hear from you. What's one change you've made to simplify your data analysis process that had a significant impact? Drop your thoughts in the comments. And if you found this episode helpful, don't forget to hit that like button. It feeds our algorithm. And trust me, our algorithm is on a strict diet of approval and validation. Once again, dear listeners, it is my pleasure and privilege to introduce the data scientist nonpareil, Cornelius P. Snarkington.
Gather round, my data-driven disciples, for a tale of true strength, a strength not found in the mere wielding of tools, but in the indomitable will that directs them. Strength is not in the sword, but in the will that wields it. This timeless adage, conjuring images of ancient warriors, is astonishingly apt for our modern world of data science. Here, our swords are algorithms, programming languages, and vast data sets, our modern weapons of choice. But what truly distinguishes a data scientist of merit is not mere proficiency in these tools. No, the real strength lies in the profound depth of domain knowledge, the intimate understanding of the specific fields to which these tools are applied. It's about grasping the intricacies of the healthcare industry when analyzing patient data, deciphering consumer behavior for retail analytics, or untangling the complexities of financial markets for economic forecasting. This domain expertise transforms raw data into meaningful insights. It is the chasm between a generic analysis and one that resonates with precision and relevance. Consider sports analytics, for instance. Understanding the game's subtleties can unveil strategies that pure statistical analysis might miss entirely. As we plunge into our daily data deluge, let us remember, our greatest asset isn't merely the data we crunch. It's the knowledge and understanding we bring to the table, the context we provide to the numbers, and the insights we draw from our deep well of domain expertise. So, my dear colleagues, how has your domain knowledge shaped your approach to data science? What unique insights have you unearthed by marrying technical prowess with industry wisdom? Share your experiences and let us celebrate the richness and diversity of knowledge in our field. Thus, in the grand narrative of data science, let us wield our swords with purpose and precision, guided always by the will and wisdom that define true mastery.
Today we're tackling a topic that's got more paradoxes than a Schrodinger's cat factory, learning from the past in data science. You've all heard the saying, those who do not study history are doomed to repeat it. Well, in data science, we've got a twisted version of that. We study history precisely because we're hoping it'll repeat itself. Now, before you start thinking we're all closet time travelers with a fetish for déjà vu, let me explain. Predictive modeling, the bread and butter of data science, is essentially us playing a high-stakes game of guess what happens next with the universe. We're like that annoying friend who's watched the movie before and keeps saying, "Oh, you're going to love this next part." Our models are based on the idea that the future will be like the past. But we're not just passive observers, oh no. We're more like delusional directors thinking we can change the script mid-scene. Our stakeholders want to adjust variables, tweak features, and pray to the gods of statistical significance that we can steer outcomes in our desired direction. It's like trying to change the ending of Titanic by rearranging the deck chairs. Now I know what you're thinking, but isn't the future inherently uncertain? Aren't we just extrapolating wildly into the unknown? And to that I say, absolutely. Welcome to the wonderful world of data science, where we use historical data to make predictions about a future that is about as predictable as a cat on catnip. But here's where it gets really fun. While we're often cautioning everyone about the dangers of extrapolating from our models, what are we actually doing? We're using these models to venture into new territory. Higher profits, lower costs, minimized risks. It's like we're using a map of New York to navigate the surface of Mars. Sure, they both have grids, but one of them has significantly more Martians. So are we just deluding ourselves? Is this all a fancy way of admitting that all models are wrong, but some are useful? Well, yes and no. It's more like all models are wrong, but some are less wrong than others, and we're desperately hoping ours falls into that category. Here's the thing. Despite all this uncertainty, despite the paradoxes and the potential for catastrophic failure, data science works. It works because we're not just blindly copying the past. We're learning from it, adapting it, evolving it to fit our ever-changing present. We're like statistical alchemists, turning the lead of historical data into the gold of future insights. Sure, sometimes we end up with fool's gold, but hey, it's shiny and in the right light, it looks pretty damn valuable. So the next time someone tells you that those who don't study history are doomed to repeat it, you can smile knowingly and say, actually, in data science, we study history because we're hoping to repeat the good parts and avoid the bad ones. It's less about doom and more about selective replication. And if they look at you like you've just grown a second head, well, welcome to the club. We data scientists have been getting that look since we first tried to explain the concept of p-values at a dinner party. Remember, in the world of data science, the past is our playground, the present is our laboratory, and the future, well, that's our next big data point. Keep predicting, keep adapting, and for the love of all that's statistically significant, keep questioning your models. Now I want to hear from you. What's the craziest prediction you've ever made based on historical data? Did it pan out, or did it crash and burn spectacularly? Drop your data disaster in the comments section. And if you enjoyed this little journey into the paradoxical world of predictive modeling, please hit that like button. It helps our algorithm predict that you might want to hear more from us in the future. This has been the Data Science Rabbit Podcast. Look for other data science rabbit hole content across social media, places like YouTube and TikTok. You can follow me, Michael Bagalman, on LinkedIn, or just visit datasciencerabbithole.com.